Hey there, Certheads. Welcome back to the channel. You are tuning into the 7th video of our SAP on Azure series, where we are tackling AZ-120 certification exam from Microsoft. This is the second video of SAP on Azure networking series. First off, a big thanks for joining me again. In today's video, we are going to continue our deep dive into networking for SAP on Azure. Let's have a look at what is on the agenda today. So we'll be looking into firewalls, well-architected frameworks for firewalls, connecting on-premises to Azure, VPNs, direct connect, different types of direct connects. We are going to build upon our Terraform script, which we had created in the previous video. We're going to create a virtual network on Azure using Terraform. Now, if you haven't set up your Terraform environment yet, don't worry, I've got you covered. Just check out the video linked above, where I walk you through setting up Terraform with Azure and VS Code step by step. We'll also look into the questions about the topics which we have already covered. And if you are new to the networking concepts, be sure to catch my first video in this series. It covers all the foundational network concepts, and we will be building upon those concepts today. So you will be up to speed in no time. We've got a lot of exciting stuff lined up, but before that, I will just like to request, if you're finding this content valuable, don't forget to like, subscribe, and leave a comment below. It really helps the channel grow and reach to more people who are on the same certification journey as you. Just share this video with anyone you might think will benefit from it. All right. Let's jump into it. All right, let's dive into something crucial for network security, firewalls. Now, what is a firewall? Think of a firewall as a building's security guard. Just like how a security guard monitors who enters and who exits the premises, a firewall monitors, filters, and controls the traffic flowing in and out of your network. Your internal network is like the secure area inside the building. Only trusted people are allowed. This firewall acts as a barrier, ensuring that only trusted data gets in while keeping out anything which is potentially harmful. Now, a lot of times people confuse between firewalls and antiviruses. Now, they're completely different and they serve a completely different purpose. A firewall is a network solution, while antivirus is an endpoint solution. Both of them play a vital role in security. They operate on different levels. Firewall is all about controlling the flow of data in and out of your network, while antivirus is all about safeguarding individual devices from malware and other threats. Now, let's discuss about evolution of firewalls. The firewalls evolved a lot over a period of time since 1989, and we want to see how they have evolved. The first generation of firewall was set up in 1989. It was basically a packet filtering solution and a port-based firewall. It was like a very first security guard who would be standing at the entrance of a building. They would check each data packet coming in or going out. They would decide whether to allow it or deny it based on a predefined rule. They couldn't see inside the packet to determine if it really carries any malicious code. Hence, we evolved into second generation of firewall. The second generation of firewall was also known as stateful firewalls. And I'll tell you what the difference between stateless and stateful firewalls. Now, stateful firewalls checked individual packets. They monitored the state of network connections. They tracked ongoing conversations between devices and would try to spot unusual or suspicious activities. Limitations on this was they couldn't really distinguish between safe and harmful data. So this was like a security guard which not only checked IDs but also kept an eye on who was talking to whom inside the building and watching any suspicious behavior. We evolved into the third generation, which was late 2000s. We saw the rise of the third generation firewall, also known as proxy firewalls for application level gateways. These firewalls acted as an intermediary between the client and the server. They would filter requests and responses at application level. This allowed them to look deeper into the data exchange. It's like having a security guard that not only checked who was entering the building, inspected the contents of the package which are being delivered as well, ensuring that nothing harmful can go through. We evolved into the fourth generation of firewall, which was after around 2010. This was combining the strength of earlier generations, and it had more advanced features. These were also known as NGFWs, or next generation firewalls. They included intrusion prevention system, IPS, and deep packet inspection. They also have application layer filtering. So they are like a highly sophisticated security system. They not only monitor traffic coming into the building, they also scan every item for potential threat and adapt to new type of attacks. They even segment the different areas of the building to contain any potential security breach. So for example, if in a building, the first and second floor have a security breach, these firewalls can isolate these two floors and the other floors will still be safe. So as you see, the firewalls have evolved. They have become much more sophisticated, just like how building security has advanced, from simple door locks to comprehensive surveillance and threat detection system. Understanding this evolution helps us appreciate how each generation of firewall has improved and how it has improved our ability to protect networks against increasingly complex threats. Stateful and stateless firewalls. A stateless firewall operates in a straightforward way. It inspects each data packet independently, looking into further basic information like packet header, source and destination IP addresses. And this is also known as packet filtering. A common example of a stateless firewall is like a network security group and an NSG, which we use in Azure. Stateful firewalls are more sophisticated security systems. They look into each packet in isolation. They also understand the broader picture. They evaluate where each packet is coming from and also what's inside the packet. So they are like a sophisticated security system. So after proper analysis, then only they allow the data to the next level. Now let's explore Azure firewalls. Now we understood what is a stateful and a stateless firewall, and what is an NGFW and how different firewalls were evolved. Azure Firewall is basically a cloud native and intelligent network firewall security service designed specifically for Azure. Since it is cloud native, it means it is built from ground up to work seamlessly with Azure's infrastructure, making it integral part of your network security strategy. The key features are: it is built in with high availability, it is offered in 3 SKUs, and it operates across layer 3 to layer 7. So when it comes to high availability, it comes built in with HA, and it is designed to automatically maintain service availability even if there is a failure in one part of the system. It's offered in 3 SKUs. So there is a standard, basic and a premium SKU. Basic is a cost-effective solution. Standard is kind of a comprehensive security package, and if you need advanced threat protection, you can go for premium. It operates across layer 3 to layer 7. If you have watched my previous videos, you will remember that these layers range from network layer all the way up to the application layer. The Azure Firewall can inspect and control traffic at multiple levels. Now you might come across another term which is very commonly used when you go for an implementation of SAP in Azure is east-west, north-south traffic. East-west traffic refers to the network traffic that moves within the trusted boundary of an environment or a data center. Now, for example, on-premises to an Azure Vnet is a trusted boundary. The communication will always happen between them. So this is an east-west traffic. What is north-south traffic? Now, if your traffic moves outside that boundary and it goes to internet, that is north-south traffic. Now, this traffic is going from a trusted boundary to an untrusted or potentially hostile network. So think of a north-south traffic as an entry and exit point of your building. These are the spots where security is tight, because this is where outside threats can enter. Well-architected framework. So a well-architected framework has 5 pillars. The first one is reliability, second is security, third is cost optimization, fourth is operational excellence, and the fifth is performance efficiency. Your design decisions should be balanced across these 5 pillars. Let's take the example of Azure Firewall and let's implement well-architected framework principles here. So well-architected framework says when you're using a Azure Firewall, deploy it in a hub and spoke topology. The firewall should be placed in the central hub network while all the other network spokes should connect back to it. This will simplify the network management and centralize the security controls. It also says that leverage AV zone for resiliency. So when you're using availability zones, you are deploying Azure Firewall across different zones, which will increase your availability, which will increase your reliability. So we covered security, one pillar, and second pillar is reliability by distributing your firewalls across different zones. Third principle, it says create Azure Firewall policy structure, increasing your security. Create a structured Azure Firewall policy and apply those policies centrally so that it's easy to manage. So you are covering security as well as you are also increasing your operational excellence. It also asks you to review the known issues list. So Microsoft would regularly update the known issues list, and those known issues list will be fed up or fed back to Azure Firewall. So this will increase your performance, efficiency, and also it will increase your security. Microsoft says monitor the health of your Azure Firewall continuously so that you know if there is a problem with the firewall, if there is any kind of threat, if there is any kind of a performance issue or configuration error. So this will increase your performance and efficiency. So as we saw that we have covered 5 pillars of a well-architected framework using these different best practices which Microsoft suggests for implementing Azure Firewall. This kind of a well-architected framework principles is easily available in the Azure's documentation. If you're going for any kind of implementation, be it a SAP on Azure, be it Azure Firewall, be it Kubernetes, you will find best practices and well-architected framework rules and regulations, which you can follow to make your implementation more robust. I've also given a screenshot of different kind of SKUs which are available in Azure Firewall. You can pause the video, go through them. It's also available in the website. I'll provide a link to the same. Now let's understand the concept of force tunneling and why it might be required. Now imagine you have an on-premises location. You have a virtual network in Azure. Both of them are connected via a site-to-site connection or an ExpressRoute connection. In some organizations, there's a requirement to force all the internet-bound traffic back to the on-premises for inspection and security purposes. But here's an interesting part. When you create a Vnet and Subnet, Azure automatically assigns a default system path to it. So what this system route does is it tells any VM which is inside the network a path to go to internet. But hey, you don't want that. You want all traffic which is internet bound, it should go to on-premises. So how do you do that? In order to do that, you add something known as a user-defined route or a UDR. Now UDR will override the default route and will redirect or force the traffic back to on-premises, and this method is called force tunneling. None of the traffic will then directly flow to the internet from the VM. All the traffic will be forced back to on-premises. I know you'll be thinking this sounds a bit complicated, right? But it's a solid approach when you want full control over your outbound internet traffic. But here's where things get even more interesting. What happens if you throw a PaaS solution like a storage account to this mix? By default, storage accounts are accessible via the internet. So if your Azure VM tries to connect to the storage account, it'll follow the internet path. And honestly, that's not ideal, especially for a security conscious environment. So how do we solve this? Well, here's a magic solution: service endpoints. Now, you create something called as a service endpoint. What this essentially does is it allows VMs to connect to the storage account via the Azure backbone network rather than traversing the public internet. This keeps your traffic secure and internal to Azure. Taking our earlier example, if we had redirected all the traffic back to on-prem, the service endpoints ensure that any traffic heading towards a PaaS service, like a storage account, would now flow directly through Azure backbone, bypassing the internet altogether. It's great, right? You have the storage account directly connected, but there is a catch to it. The storage account will still be accessible via internet. So while your internal traffic is secure, external access to the storage account still remains available unless additional steps are taken to lock it down. Pretty cool, right? Force tunneling, UDR, service endpoints, all of these work together to give you a complete control over your network traffic, both on-premises and in cloud. Let's take things a step further and talk about private endpoints and why they are useful. So service endpoints are great for securely connecting Azure PaaS services. They keep the traffic inside the Azure backbone, which is fantastic for internal security. However, there are two downsides to it. Service endpoint will still leave the service exposed to the outside world. Also, service endpoints don't work with traffic originating from the on-premises networks, whether through a VPN or ExpressRoute, etc. Those cases, you need to whitelist the IP address in your firewall, which is sitting on the hub network. A bit of an extra work. So what's the solution to this challenge? So that's where private endpoint comes in. It's a newer solution compared to service endpoints. It is designed to close the security gap. Instead of routing the traffic to the public internet, the private endpoint allows PaaS resources to have an internal IP within your Vnet. This means that the resources will completely have a private IP and a private communication, and there will be no communication to the outside world. It entirely locks down within your Vnet. Now let's understand how this works. So when a PaaS service is created, it is publicly accessible and it has a DNS name. This DNS name allows you to resolve that particular service from internet. So when you enable a private endpoint, the Azure PaaS resource, which has a public DNS record, also known as canonical name record, CNAME record, is overridden with a private endpoint DNS setting. So instead of resolving the public IP of the PaaS service, the DNS now resolves the public IP to a private IP. So you always connect to the PaaS service. Your DNS redirects the query to the private IP instead of the public IP. So this is how the private endpoint makes sure that the PaaS service, be it a storage account, be it a database, those instances are only accessible privately. They are not accessible from internet. Private endpoint provides a way to securely connect to Azure PaaS services while keeping those services completely isolated from the public internet. So now we have understood service endpoints, private endpoints. Let us go ahead and create our virtual network using the Terraform setup which we had created earlier. So far we have only created a resource group. Now we are going to build upon it and create a virtual network and a subnet within it. Alright, so let's move ahead with our Terraform setup. In our last setup, we had created a resource group with the Terraform code. We're going to build upon that and we are going to add a Vnet and a subnet to it. So I'll open my Terraform repository. So we had created a main.tf which contained the resource Azure resource group and a name and the location where the resource group needs to be created, and then we gave a name of the resource group. Now we should be creating another resource, and the resource type is Azure RM Vnet or a virtual network. Let's give it a name. Let's say AZ-120 Lab Vnet, and we will see what are the required properties. One of the required properties is name. So I have given it a name AZ Vnet Lab 01. You can give any name which you want. It's perfectly fine. The next attribute is a resource group name. Now it is asking for a resource group name. We want to give it the name of the resource group which we had created earlier. So how do you do that? So you are going to point to the block, the resource block which we had created earlier. So in order to do that, we just type in Azure RM underscore resource group dot AZ-120 Lab RG. So what this does is, it's now pointing to this particular block, and from this block I am going to pick up name. Similarly, for location, I am going to point to this block and pick up the location. And then there is an attribute called address space, which is done. Now we have added the VNets. Now let us go ahead and add the subnets for this VNet. So the command for that will be resource Azure RM underscore subnet. We'll give a name to this resource block. Say AZ-120 Labs sub 1. Remember, this is just a name which is used for calling the resource block. It has no significance with the resource which is going to get created. Okay, so the attributes which are required for this resource are the name of the virtual network. So I'm going to pick that up from the previous resource block. So this is where the resource block name is required. So Azure RM virtual network name, virtual network, and the resource block name. So I have called Azure RM virtual network dot AZ-120 Lab Vnet, which is the resource block name. And since I need the name attribute from that resource block, I'll just say dot name. So Terraform will pick up the name of the virtual network from the previous block. Another attribute which is required is resource group, which is I'm going to pick up from the resource group block. Azure RM resource group AZ-120 Lab RG is the name of the block of the resource group, and I'm going to pick up the name from there. And finally, we need the name for the subnet, which should be a string. I'll just give it a name workload subnet, and then we need the address prefix. Here we go. So remember, address prefixes, we have used ipcalc, which I have discussed in my previous videos, and we just have to copy paste this particular block and create 4 subnets. So let me do that. Okay, I have already done that. As you can see, there are 4 resource blocks which are created, or 4 subnets which are created. The first is the workload subnet, that is the address prefix. Second is the gateway subnet, that is the address prefix. Third is the firewall subnet, name and the address prefix. And the fourth one is the management subnet, firewall management subnet, name and the address prefix. So what we can do now is, just for the code readability purpose, give it a description. We have to save the file and run Terraform fmt-recursive. So what this does is it formats your code. I mean, if you run this particular command, you can see everything gets tidied up in the code. So this is a cool feature of Terraform. Next, we will run Terraform init. It has run. Then we will run a plan to check what are the resources which will get deployed. So it says plan 6 to add, 0 to change, 0 to destroy. So it's going to add 6 resources. So let's go ahead and command Terraform to apply it, and with an auto approve tag. Remember, auto approve is only for testing purposes. Do not use it in production. So it says apply complete, all the resources are added. Great, let us go to the portal and quickly check. So as we can see, there is a certed lab RG01 which is created, and there is a Vnet inside it, and there are subnets which we had defined in the Terraform script which are already created. Great, so we have created a Vnet and subsequent subnets inside the Vnet using the Terraform code, and we are going to use this Vnet and subnet for the demo purposes in our labs which are upcoming. Okay folks, we learned a lot about firewalls, we learned a lot about UDRs. Let's try to put that in practice. Let's have a demo and we'll try to create Azure Firewall and we'll see how it is done. We'll go to the Azure Vnet and you will see an Azure Firewall option here. We'll click on that. We'll click on add a new firewall. Now before I go ahead and show you how to add a firewall, I would just like to show you the Vnet which we had created using Terraform and the subsequent subnets. The Vnet is this AZ Vnet Lab 01 and we have this address space. There are 4 subnets: Gateway subnet, Azure Firewall subnet, a workload subnet, and an Azure Firewall Management subnet. Okay, good. Coming back. Let's click on Azure Firewall. Click to add a new firewall. Let's give it a name. Test Firewall 01. We don't need any availability zone. The SKU should be basic. Firewall policy, we don't have any policy. We'll add new. We'll say FW-POL01 Firewall Policy 1. Under virtual network, we will use the existing virtual network. And in the virtual network, we already have created 2 subnets: Azure Firewall subnet and an Azure Firewall Management subnet. So one of the subnets is used for managing the firewall, which is the Firewall Management subnet. Another is for firewall itself, which is the Azure Firewall subnet. Now when you create these subnets, you have to use exactly the same naming convention: Azure Firewall subnet and Azure Firewall Management subnet. Same goes with Gateway subnet. Okay, let's go and create a public IP address for the firewall. Let's give it a name, FW pub 01. Click on OK. And it needs a management public IP address as well. So this public IP address will be used for connecting to the firewall for management purposes. So we will create a new one. FW-mgmt-pub01. Click on next. Next. And if the validation completes successfully, we can go ahead and create. Meanwhile, while the firewall is deploying, I will go ahead and create a virtual machine. This virtual machine will be used for testing purposes. So So we will be using or restricting the access to the traffic to the virtual machine using firewall. Okay, now both the resources are deployed. We have a virtual machine and we have the firewall ready. Now what we are going to do is we are going to make the virtual machine go through the firewall. Now how do we do that? We already know there is a system route which is automatically assigned when you create a Vnet, a Subnet and a virtual machine. It already has a system route. Now we are going to override that. We're going to ask the virtual machine to go via the firewall. So how do we do that? We use a UDR, user defined route. So let's see how we do that. So we will go to all services, UDR, route tables. We'll click on create. We'll select our resource group, region UK South, name, you can say firewall route. We'll click on review and create. Now we are just creating the route table. Next we will associate the route table and then we will add a route to it. So the route table is now created. We'll go to our resource group and we can see there should be a route table, and we can see there is a firewall route table which has been added already. So what we are going to do is we are going to go to the route table and we're going to select subnets, associate. It has already found one Vnet, so we are going to associate this to the workload subnet. Click on OK. So now this route table has been associated to the workload subnet. We are going to add some routes. Select routes, click on add. The route name we will say firewall EG. For address prefix destination we will select IP addresses. IP address destination we will say 0.0.0.0/0. The 0.0.0 specifies any traffic which goes outbound to internet. The next hop type is basically we are telling the route table that the next hop type should be a virtual appliance. Virtual appliance in this case is our firewall. And the next hop address, we have to put the firewall's IP address, which you can see in the overview page. We'll click that, copy that, paste it here, and click on add. So we have a route table created, we have associated it, we have given it a route. Now any traffic originating for the internet from the VM will follow the default route, which is it'll go to the virtual appliance. So virtual appliance is the firewall, and the firewall will decide what to do with the traffic. Now how will the firewall decide? We have to tell the firewall what it needs to do. We have to create some kind of a rule. So let's see how we can do that. We'll go to the firewall. We'll go to the firewall policy. We'll select application rules. Click on add a rule collection. So for the name we'll say app collection 01. Priority we can give 200. Rule collection action, what action it should take, we can say allow, and it has put it under a default rule collection group. So this is the rule which we have to create. So let's give it a name, allow Google. So we want to allow only google.com. For the source type we'll select IP address. For the source type we will give IP address, and for the source we will give the subnet CIDR of the workload subnet where the virtual machine is sitting. Click on the subnets, and this is the subnet CIDR. You can copy it, paste it here, Protocol, we will say HTTP or HTTPS. Now for the destination type, we'll select FQDN, and the destination we will say www.google.com. Click on add. We need to also create network rules. Let's click on network rules, add a network rule. Then let's say network selection 01, priority you can say 200, rule collection will allow, and default network rule collection. For the name we can say allow DNS. Again, source will be the subnet, and the protocol will be UDP, and the port, destination port will be 53, and the IP addresses for the destination will be 209.244.0.3 and 209.244.0.4. This network rule has been added in order for your VM to go for a DNS resolution. The public IP address which have been provided are from level 3. It's a company which provides free DNS service. So we'll click on add, and next we are going to add DNAT rules, which is destination NAT rules. We'll click on add. Again, same, add a rule collection. Name we will say RDP. So the reason we are adding this rule is we are trying to use the firewall to RDP into the VM. You might have noticed we did not have any public IP address on the VM. Okay, good enough. Let's give it a priority 200. Rule collection. This is a DNAT rule collection. Name we can say RDP-NAT. IP addresses, source we can just give star here. Star means any. Protocol, we'll select TCP. Destination port range 3389, that's the RDP port. Destination IP address we will select the firewall's IP address. Which is this one. Copy. Paste. For translated type, we'll select IP address. And the translated address. The translated address, we will provide the private IP address of the virtual machine. This is the private IP address of the virtual machine, and the translated port we will say 3389. So this rule which we added is basically using a NAT. NAT is basically a network address translation. We have discussed this in the previous videos. Any traffic which lands on the public IP of the firewall on this specific port 3389 will be allowed back to a private IP address, which is the virtual machine's private IP address on that specific port. So this is, we are hiding the private IP address of the virtual machine. Instead, we are using the firewall's public IP address, and we are able to access the virtual machine via the firewall. Okay, now just one more thing which we need to do is we need to change the DNS. We'll go to the virtual machine, we'll go to the DNS server, and under DNS server, we will select custom. So we want this virtual machine's DNS to be resolved via the custom DNS servers which we used, which is the level 3's DNS server. Now we do need to restart the virtual machine after we have this saved. Okay, now we have added the rules. The virtual machine is ready. We have added the DNS servers as well. Let us try to connect to the virtual machine. Now, if you click on connect on the virtual machine, you will probably find only the private IP address. There's no public IP address. However, we will be using the firewall's public IP address. Let's go to the resource group. Let's find out what is the firewall's public IP address. So we had assigned FWPub01 as the firewall's public IP address. This is the IP address. I'll try to connect to it. And we are inside the virtual machine. Let's click on Internet Explorer. Let's try to browse some other websites like Microsoft.com. So it's saying action deny, reason no rule matched, proceeding with default action. Default action is deny. Let's try to browse google.com, which we had allowed. And you can see we are able to log in, or we are able to browse to google.com. So this means that the firewall is working. We are able to connect to the firewall. We are able to connect to the virtual machine through the firewall. So the firewall is acting as a NAT device. The firewall is also blocking and allowing certain traffic to go through. In this case, we are only allowing a web page, google.com, to be accessible on the VM. We have also created a UDR, a user-defined route, so that any traffic inbound, outbound, it always goes through the firewall. But we already talked about user-defined routes in our previous slides, and we understood that when you create a virtual network in Azure, you are automatically assigned a system route which is assigned to each and every subnet. Sometimes you want to have more control over the traffic. In those cases, you might create custom routes, which are also called user-defined routes. These user-defined routes override the default system routes with your own rules. You can dictate where exactly your traffic should go. All right, let's take it up a notch and talk about Border Gateway Protocol, or BGP. Now, this is one of the most widely used protocols on the internet. So what exactly is BGP? BGP is like internet's GPS system. It helps the routers determine the best path for sending data between different networks, whether you are connecting from multiple service providers or whether you are scaling up your network. So imagine that internet has a massive web of interconnected resources. Each is managed by different organizations or service providers, and these networks are called AS, or automated systems. Now these AS need to communicate with each other, and BGP is the protocol that facilitates these communications by sharing the routing information between them. So the routers communicate to each other and share routing information in between them. Think of BGP as the mail carrier of the internet. When the data needs to move from one network to another, BGP routers exchange routing information. It is sort of like exchanging maps between each other to show the best possible routes. In a nutshell, BGP helps ensure that the data finds its way through the complex maze of networks that make up the internet. It's like a navigation system that constantly updates on current conditions, ensuring the data moves as efficiently and securely as possible. Net connectivity. So let's say that you have an on-premises network and you need to connect to an Azure Vnet. There are two main ways of doing it. One is through a VPN, a virtual private network, or a direct connect. A virtual private network is something which allows your device to connect to a required network and get a private IP address out of that network. This means that when your device connects, the device itself becomes a part of that network, and the network recognizes that device as a part of itself. Let's start with the point-to-site VPN. Think of it as a solution for individual users who need to connect to Azure Vnet from anywhere in the world. You're probably working from your home or maybe from a coffee shop. Point-to-site VPN helps or lets you connect your laptop directly to the Azure Vnet using something called as SSTP or OpenVPN. SSTP is Secure Socket Tunneling Protocol. Now, this is great for smaller teams or individuals working remotely, but if you have a larger team or multiple people connecting from different locations, this might not be an efficient solution. So what is the solution then? S2S, or site-to-site. This is more suited when you need to connect your entire on-premises environment with multiple users back to Azure Vnet. This site-to-site VPN uses IPsec or IKEv2 tunnel. It allows multiple users from a certain site to connect to your Vnet via VPN connection. So all your devices on premises now can communicate with the resource in Azure Vnet, just like they would with any other device on the same local network. Pretty powerful, right? Let's go ahead and perform a quick demo. We'll create a gateway subnet. We will create a gateway in the subnet, and we will see what it contains. Let's try to create a gateway and see what are the settings in the gateway. So let's click on create, and we'll type in virtual network gateway. Click on create. Give it a name, Vnet gateway certed 01. Region is UK South. So observe that you have two options here, VPN gateway or ExpressRoute gateway. Based on the selection, the SKUs and everything will change. So you always need, as I told earlier, you always need a gateway either for a VPN or an ExpressRoute. So let's select VPN, and SKU is VPN GW2. We just want a basic one. Generation 2 is fine, and let's select a virtual network, which is our EasyLab Vnet, and it has automatically picked up the gateway subnet. If you go back to our Terraform code, we had created a gateway subnet and we had given it address prefix. You have to make sure that when you create a gateway subnet, you follow the naming convention, which is gateway subnet. Public IP address, we have to create a new. So let's say gateway pub IP01. So gateway subnet is associated. We'll create a new public IP address, gateway pub IP01, and that's it. Let's create. We're not enabling BGP as of now because we're just trying to study the VPN device or the gateway. Now still the gateway is getting deployed. However, we can go and look into the configurations. It is an SKU which is VPN GW2, and we can enable BGP, but as of now we don't need it. And click on connections, and it will give you an option to add connection. And here, important thing to note is the three types, Vnet to Vnet. So you can create a gateway for communicating between Vnet to Vnet if you are not using Vnet peering for some reason. There's a site to site, and there is an ExpressRoute. So you can create these three options here. So that's a brief overview about VPN gateway. Now the VPN solutions, whether it's point to site or site to site, are fantastic for administration tasks and basic connectivity of your virtual machine or Azure resources. They help you to create, securely connect your on-premises network to Azure Virtual Network. That's fine. And they are ideal for, handling a small amount of traffic. But when you have a large amount of traffic, you cannot rely on VPN because it anyways goes through the internet and it may break. So then what do? You look for another kind of a solution, and that solution is called Azure ExpressRoute. Now, if you're looking to extend your on-premises to Microsoft's cloud via a private connection, you go ahead with ExpressRoute. ExpressRoute lets you bypass the internet and create a direct connection between your on-premises and your Azure data center with a dedicated, direct, low latency, highly reliable link. It is perfect for data-heavy operations, enterprise workloads, or anything where performance and consistency are crucial. Normally, when you set up an ExpressRoute, it connects through a gateway. The gateway helps manage routing between on-premises and Azure. Now, if you are dealing with some serious workloads, especially services like SAP, the gateway might not provide you the exact bandwidth which you are looking for. So in those cases, Microsoft provides you an option to go ahead with another kind of ExpressRoute, wherein the setup remains the same, but the connectivity will bypass the gateway and you will directly connect to the networks. Now, you would still need a gateway because you need to exchange the routing information between the networks, but the data connectivity will bypass the gateway and it will directly connect to the virtual network. Now, imagine that you have multiple offices around the globe. You have offices in US, you have offices in UK. Let's say you want to establish connectivity between these offices and different Azure regions as well. Basically, you want to make it feel like one global network. This is where ExpressRoute GlobalReach comes into picture. With GlobalReach, you can create a private network that links various on-premises locations and Azure regions across the world. So whether you are transferring large data sets or running mission critical applications, you can do it smoothly across regions. You can basically create one whole global network across different offices situated in different parts of the world. All this is good and great, but you would see that we are bringing in a lot of solutions. We are bringing in ExpressRoute, we are bringing in VPNs, we are bringing in point-to-site VPNs, site-to-site VPNs, FastPath, GlobalReach. It becomes very difficult if your organization is using all these solutions together. So what Microsoft has done is they provide another solution which is called Azure Virtual WAN. Now what this virtual WAN will do is it is simplifying the global connectivity by allowing you to take advantage of the scale of Microsoft's global network. So imagine that you have company branch offices across different regions, main offices in different regions, and there are remote users who are coming in from another region. So you have, let's take an example that these all headquarters, branch offices, and remote users coming in from Europe, US, and Asia. Now each need different connectivity options. Remote users needs VPN site point to site, branch offices may need site to site, and the headquarters may need an ExpressRoute connection. So instead of managing all these connectivities individually in each branch, Azure Virtual WAN will let you manage everything centrally as one unified entity. So instead of managing all these connections individually at each branch, Azure Virtual WAN lets you manage everything centrally as one unified entity. You can deploy termination points of these remote VPN users as well as site-to-site VPNs and ExpressRoute connections all under one umbrella. Whether you are connecting branch offices in Asia or headquarters in North America or whatever is the region, you can enable remote users to securely work across different sites. So this virtual WAN is providing you a simple process, a simple way of managing all your connectivity. Instead of juggling to different network connections or configurations across different locations, it helps you manage everything under one centralized point. This means less complexity and more efficient. The right solution depends on the organization's size, need, and scalability requirements. Now, if you are just starting out with a smaller team, probably point to site may be the solution which you need. And when you have a set of people and your team grows, you can use site to site connectivity. Now, if you are looking to migrate large amounts of data across the data centers, you can go for ExpressRoute. And when you are bringing in different offices from different regions of the globe, a global connect. So based on your requirement, you can choose the solution. Now let's explore some questions related to the topics which we have covered till now. You have an SAP environment on Azure. You have an on-premises network which connects to Azure by using site-to-site VPN. You need to alert technical support if the network bandwidth usage between on-premises and Azure exceeds 900 Mbps for 10 minutes. What should you use? The answer is you should use Azure Monitor. Azure Monitor is a comprehensive solution for collecting, analyzing, and acting on telemetry of the Azure resources. Next question, you need to design an Azure network infrastructure to meet the following requirements. Prevent end users from accessing database servers. Isolate the application servers from the database servers. Ensure that the end users can access SAP system over the internet, and minimize the cost associated to the communication between the application servers and the database servers. What should you use? So the answer to this is create a site-to-site VPN between the on-premises networks and Azure, and in the same Azure virtual network, segregate SAP application servers and database servers by using different subnets and network security groups. Next question. It is estimated that during the migration, the bandwidth required between Azure and the New York office is 1 Gbps. After the migration, the traffic burst of 3 Gbps will occur. Once the migration is complete, to which size should you set the ExpressRoute circuit, the New York office, to meet business goals and technical requirements? So the answer to this is 2000 Mbps. Now why it's 2000 Mbps? The estimated bandwidth during the migration is around 1 Gbps. and to accommodate a potential traffic burst after migration, you need additional capacity. A burst of 3 Gbps is mentioned. So considering the estimated bandwidth and potential bursts, setting ExpressRoute circuit to 2000 Mbps would provide sufficient capacity for both the scenarios. You have an Azure subscription, you deploy Active Directory domain controller on Azure virtual machines, and you plan to deploy Azure for SAP workloads. You plan to segregate the domain controller from SAP system by using different virtual networks. You need to recommend a solution to connect to the virtual network. The solution must minimize the cost. The answer is you should use virtual network peering. It's simple, it doesn't cost you anything, and it's the best way for communicating two different virtual networks. So folks, in this video, we have covered some really exciting topics and concepts. Right? We have dived in deeper into Azure networking, and we have also built upon our Terraform skills. By now, you should be feeling more confident with Terraform, and you should have a better understanding of how straightforward it is to use, especially when it comes to managing your infrastructure. This was a part 2 of the video series on Azure networking for SAP, and the next and the final part will wrap up all the key networking concepts which you would need to go for the certification exam. Thanks for watching, and I'll see you in the next one. Don't forget to like, subscribe, and share your thoughts to the comments box. I'll see you soon.